Hey guys, welcome to your maths class. Good to see you again. Our today's topic is HCF LCM product of primes. So let's get to know what are these terms. First, we need to know what is a common factor. When you find the factors of two or more numbers and then find some factors are the same, then they are known as common factors. For example, factors of 12 are 1, 2, 3, 4, 6, and 12. And factors of 6 are 1, 2, 3, and 6. So the common factors of 12 and 6 are 1, 2, 3, and 6. I hope you got it what is a common factor. So let's move forward. Now we need to know what is HCF. HCF is highest common factor. So to know HCF, we need to know first what is a common factor. The largest common factor of two or more numbers is called the highest common factor. Now, you need to see the example. Factors of 12 are 1, 2, 3, 4, 6, and 12. And factors of 8 are 1, 2, 4, and 8. So the common factors of 12 and 8 are 1, 2, and 4. Here you can see the largest common factor is 4. So the highest common factor of 12 and 8 will be 4. Basically, the largest common factor between two numbers is known as the highest common factor. Not so difficult. Now we need to see a practice question. The question is find the highest common factor HCF of 60 and 96. So the factors of 60 are, as you can see, 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, 60. And factors of 96 are 1, 2, 3, 4, 6, 8, 12, 16, 24, 32, 48, and 96. The common factors of 60 and 96 are 1, 2, 3, 4, 6, and 12. As you can see, I have bold the common factors between 60 and 96. So these are the common factors between these two numbers. Here you can see the highest common factor. This is 12. Now these are some questions which you need to do it yourselves. Not so difficult. You need to follow these practice question, this example, and then you will be able to solve these practice questions. Let's move forward. Now, to know about LCM, first we need to know what is a common multiple. When you find the multiples of two or more numbers and then find some multiples are the same common, then they are the common multiples. For example, multiples of 2 are 2, 4, 6, 8, 10, 12, and so on. So basically multiples, as you have read before, that these are the 2 times table. As you go see the product of the 2 times table, these are basically the multiples. And same goes for multiples of 3, 3, 6, 9, 12, 15, 18, and so on. So here you can see the common multiples can be 6, and as you move forward you can see 12. So the common multiples of 2 and 3 in above example are 6 and 12. So from the 6 and 12 you can see the least common multiple is 6. Now we will read about least common multiple. LCM, the least common multiple of two numbers, is the smallest number that is not 0 that is a multiple of both numbers. So in the example you can see that multiples of 2 are 2, 4, 6, 8, 10, 12, and so on, and multiples of 3 are 3, 6, 9, 12, 15, 18, and so on. So the common multiples of 2 and 3 in above example are 6 and 12. So the least common of 2 and 3 is 6. Here is a practice question. Find the lowest common multiple of 60 and 96. Multiples of 60 are 60, 120, 180, 240, 300, 360, 420, 480, and so on. And the multiples of 96 are 96, 192, 288, 384, and 480. So the least common multiple of 60 and 96 is 480. Now these are some questions which you need to do yourself. So the questions are find the LCM of 120 and 150, find the LCM of 24 and 64, find the LCM of 75 and 90. Now here Here's an important topic, that is product of prime factors. First we need to know about prime factorization. Prime factorization is finding which prime numbers multiply together to make the original number. For example, finding prime factors of 12. It is best to start working from the smallest prime number, which is 2. So let's check. 12 divided by 2 gives us 6. Yes, it divided exactly by 2. We have taken the first step. But 6 is not a prime number, so we need to go further. Let's try 2 again. 6 divided by 2 is equal to 3. Here you can see that 3 is a prime number. So yes, that worked also, and 3 is a prime number, so we have the answer. 12 is equal to 2 multiplied by 2 multiplied by 3. Here is our answer of product of prime factors. As you can see, every factor is a prime number. So the answer must be right, as it cannot be factored furthermore, and these all are the prime numbers. So the product of prime factors is the answer. We can also write it using exponents. 12 is equal to 2 squared multiplied by 3. I hope you got my point. Here is a practice question. Find the prime factors of 147. So as you can see, according to your estimate, this is not an even number, so it cannot be divided by 2 so that you can get a whole number as your product. So you need to check. Here you can see, you can check it even, that when you divide 147 by 2, you get your answer as 73 divided by 2. And no, it can't. The answer should be a whole number, and 73 divided by 2 is not. Let's try the next prime number, that is 3. So when we divide 147 by 3, we get our answer as 49. So as 49 is a whole number, so we can move forward. That worked. Now we try factoring 49 and find that 7 is the smallest prime number. That works. So when we divide 49 with 7, which means that when we divide it with 2, we divide it with 3 and more numbers, we were unable to get a product as a prime number. So when we divide 49 by 7, we get our answer 7, and that is as far as we need to go, because all the factors are prime numbers. Here you can see that 3, 7 and 7, all of them are prime numbers, so we can also write them as using exponents. 147 is equal to 3 multiplied by 7 squared. I hope you got this, not so difficult. Here is another question. Now you need to find prime factor of 17. So you divide it by the smallest prime number, that is 2, and you do not get a whole number as your product. You use 3, you go for 4, you 5, 6, 7, and then as you can see that 17 is a prime number, so you cannot divide it by anything else other than 1 and the number itself. So 17 is the prime factor of 17. Now here is another question, that is find prime factors of 90. As 90 is an even number and is also a multiple of 10, so that is easy for you. You can break 90 into 9 multiplied by 10, and you can find the prime factors of 9 and 10 separately. That is, the prime factors of 9 are 3 and 3, and the prime factors of 10 are 2 and 5. So the prime factors of 90 are 3, 3, 2 and 5. Here you can write like 90 is equal to 2 multiplied by 3 multiplied by 3 multiplied by 5, like this, and you can use exponents. 90 is equal to 2 multiplied by 3 squared multiplied by 5. This is your answer. Now, a factor tree. What is a factor tree? A factor tree can help find any factors of the number, then the factors of those numbers, etc., until we can't factor any more. For example, find prime factors of 48. Here you can see that we have a number 48. Divide 48 by 2, and you get your answer 24. And now you can see that 22 is a prime number, and 24 can be factored furthermore. So we divide 24 by 2 again, and we get an answer 12. Now, as you can see, 2 is a prime number and 12 can be factored furthermore. So you divide 12 by 2 and you get your answer 6. And 6 is also not a prime number, it can be factored furthermore. You go on, divide 6 by 2 and you get your answer 3. Now you can see that both factors of 6, 2 and 3 are prime numbers, so they cannot be factored anymore. And you get your answer. The product of prime factors of 48 are 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3, and you get your answer as 2 to the power 4 multiplied by 3. Life is an open book, ready to turn the next page. Yeah, we always turn the next page. Why find prime factors? A Prime number can only be divided by 1 or itself, so it cannot be factored any further. Every other whole number can be broken down into prime number factors. It is like the prime numbers are the basic building blocks of all numbers. This idea can be very useful when working with big numbers such as in cryptography. You can search on cryptography. It is a modern technology for keeping your code secret. Here is an assignment for your own practice related to prime factors, product of prime factors. Not difficult, as I have mentioned all the techniques regarding the product of prime factors, so you shouldn't find it difficult. Self-belief and hard work will always earn you success. I hope you got my point. So from this quotation you come to know that self-belief, you need to believe in yourself, and you need to do hard work. These both will combine to make you hardworking, and it will make you a successful man. Thank you. Keep following my tutorials. I'm your tutor Shahriz Salman, and your reference website is www.sensebusiness.co.uk. You can follow my this website and keep following my lectures for getting further information regarding maths and master yourself in this subject. Thank you so much. Take care. Goodbye for now.